Welcome to a lesson with Dr. Pal. Let's take a look at how Boolean algebraic expressions can be thought of as subsets of a larger set, or kind of a set of everything. So, for instance, let's start off with two different statements, A and B, and let's look at an expression that looks something like this. A and B, or not A, or something like this. Now, if we take a look at this, we can think of, we have two variables. Let's see what the output of the expression is. When A is true, which we'll say is 1, and B as, okay, so A is true, B is false, 1, 1. So let's look at the different possibilities. 0, 0, and 0, 1. Okay, so there's 4 different possibilities. So let's just think about what we get. So we think 1, or let's see, 0, or, and not A would be if, so I'm looking at the first line here. So thinking of A as being 1 and B as being 0. So this would be not 1. So this would be like 0, right? So 0 or 0, which would just be, so not, this expression not means opposite here. So opposite 1 would be false. And so we're thinking of 1 as being true and 0 as being false. And loosely speaking, if as you do this, think of this as union. Think of 0 as empty sets. So empty union set, empty set is just, or just false or false. It's false. So that's false. And true and false, I mean, well, this means the intersection of empty set and 1. Think of it as everything. So everything intersect, not empty set is just empty set. So that's just 0. So we can think of this as just being 0. I like to think about these symbols as intersection and union, and it helps me as I'm thinking about empty set versus a set of everything. It allows me to compute those expressions. So I get 0. Now, if I go through this one, A is 1 and B is 1, go through that, I end up getting 1. And you could think, so 1 intersect 1 union empty set. That's just going to be 1. You can see how that would be 1 if I'm putting 1 and 1 in there. Okay, so not 1 would be 0. So then if I put zeros in, that would be 0 intersect with something else. That's just clearly 0. This next one is 0, 1. Well, it's again 0 intersect with something's clearly 0. This actually means that this particular expression, if we look at this right here, this is, see this list of zeros and ones, look at where it's 1. This means that we can think about this expression as being a subset of my different possibilities. The different possibilities that we have for every single expression, or Boolean algebraic expression A and B, are not A, why don't we start with A and not B. So that's like representing the first line, or A and B represents the second line, or not A and not B, which represents the third line. See, the zeros represent nots, and the ones represent just the variable. Then we have not A and B. So we have so basically every expression is going to be, we're going to say that two expressions are the same if and only if they are given by the same subset of this set. So we're gonna say that the subset that this particular expression is equivalent to of this is the subset of elements that cause a 1 over here. So the subset of elements, well, that's just A and B. So it's equal to the subset A, and so just with that singleton element in that. So in that way, we can think of an expression as being a subset, and the full set is just the set of full possibilities here. Thanks for watching.